Good day, students and viewers. In this video lecture, we are going to consider permutations and combination. The word permutations simply means arrangement. To arrange items in a particular order, we call it a permutation of the items or the object. And so, suppose we have 5 objects, or suppose we have 3 objects, which are A, B, and C. We want to see the number of ways we can arrange these items as 3 distinct items. Then we say, okay, we can have first arrangement can be A, B, C. The second one can be A, C, B. This is another different arrangement. Another different arrangement can be B, A, C. Another arrangement can be B, C, A. Another arrangement can be C, A, B, and then C, B, A. These are 6 different arrangements, and there is no 7th. And so we are arranging n items all at once, taking all at a time. Then the number of ways of doing that is given by n factorial, and n factorial is written as this, n with an exclamation. We call it n factorial, and this is the product of n integers starting from 1 to n, meaning n factorial is equals to n times n minus 1, keep on reducing 1, times n minus 2, keep on reducing 1, times, you keep on reducing until you reach times 2 times 1. So that is it. For example, if you have 3 factorial, we have 3 items here, and so I have 1, 2, 3 items, so I have 3 factorial, and this is given by 3 times 3 minus 1 is 2, times 2 minus 1 is 1, so until you reach 1, and this is equal to 3 times 2 times 1, and that is equals to what? 6. So we have 6 ways of arranging 3 items, taking all at a time. And we have a permutation, a kind of arrangement that we can arrange items taking a specific number of items at a time. An example we have, or let me write the formula, the permutation of n items taking r at a time. This is always given by n factorial over n minus r factorial. So you have n items, you want to arrange them picking 2 at a time, arranging them in 2, and then in how many ways can you do the arrangement. So this is given by n factorial, which I have explained here. It is n times n minus 1 times n minus 2 times until you reach 1. So this is n minus r, meaning this number minus this number. Suppose we want to find the form, we want to let's have an example. This example is saying in how many ways can 3 students out of 5 be arranged in a line, So you look at it, this is n, this is r. Always n is greater than r. N is always bigger than r. So you see, in terms of arrangement, if you are looking, see 3 students out of 5. So 5 is greater than 3. So your n is 5 here and your r is 3. So the formula to solve this, you use the formula permutation of n objects. N is 5 here, out of, you are picking 3 out of, so you are picking 3 out of 5. So your r is this. So n factorial, but my n equal to 5, my r equals to 3. So I have 5 factorial over 5 minus 3 factorial. And this is equals to 5 times 4 times 3 times 2 times 1 all over 5 minus 3 factorial, which is the same thing as saying, okay, factorial. I have 5 times 4 times 3 times 2 times 1 over 5 minus this minus 3. The answer is 2 factorial. But this is equals to what? 5 times 4 times 3 times 2 times 1 over 2 times 1. So 2 cancel 2. I have 5 times 4 times 3. 5 times 4, 20. 20 times 3, the answer is 60. So I have 60 ways of arranging 3 boys out of 5 boys. So if you have 5 boys, you can arrange picking 3, and you can arrange them in 3 in 60 ways. The number is big. 60 ways of arranging 5 students. An example we can give here is if you are arranging, let's say you are arranging 2 students. You are arranging 2 students out of from 4. Number of ways of arranging this. So this is going to give us 4 factorial over 4 minus 2 factorial. And this is equals to what? 4 factorial over 2 factorial, because 4 minus 2 is 2. And this is equals to 4 times 3 times 2 times 1. And this is equals to 2 times 1 for this. So we have 2 will cancel 2. 1 will go with 1. We have 4 times 3. This is 4 times 3. And the answer is 12. So you are doing this in 12 ways. That is the number of ways of arranging 4 students. You are arranging students into 2. The number of way of this arrangement. And so we have another, the second concept is the combination. A combination simply has to do with the number of ways of choosing some items out of a given number of items without considering the order. We don't care about the arrangement, but in how many ways we are after. How many ways can you choose a number of specific items from a given number of items? For example, if you are given 10 students and you are asked to choose 2 out of the 10, in how many ways can you select those 2 students out of the given number of students, which is 10? So, and the formula is given by combination of, say, n objects r, choosing r at a time, and this is given by n factorial over r factorial into n minus r factorial over and r factorial. This is the formula to choose r objects out of the given n objects. So we can have example. An example we have here is example, in how many ways can we select 2 fruits from 4 fruits? The 4 fruits are given as apple, banana, orange, and mango. In how many ways can you do? All we are after is that we are choosing 2 out of 4. So your n is always greater than r. So in this problem, your n is equal to 4 and your r is equal to 2. So we use the combinatorial formula of choosing, or say combination. So we said, okay, the combination 4, choosing 2 at a time, because our r is 2, is the same thing as 4 factorial over 2 factorial into 4 minus 2 factorial. And this is equals to 4 factorial over 2 factorial times, you can put multiplication sign if you don't mind, or you just write 2. So we have 2 factorial, because this is 4 minus 2 giving you 2, and there's a factorial sign, and we have original 2 here sitting, so there's a factorial. So you have 2 factorial times 2 factorial. You can write them side by side, 2 factorial, which we always understand it to be a kind of multiplication between the two, meaning 2 factorial times 2 factorial always. So we can write this to mean multiplication, 2 factorial, 2 factorial. And this is equal to 4. I want to evaluate the factorial now. Times 3 times 2 times 1 divided by 2 times 1 times 2 times 1. This for the second factorial and this for the first factorial. So what we have is 4 times 3 is 12. 12 times 2, the answer is 24. Divided by 2 times 1, 2. Times 2, 4. Times 1, 4. So I have divided by 4. So 24 divided by 4. The answer is 6. So we are choosing two fruits out of 4 fruits in 6 different ways. So that is the notion of permutation and combination. Permutation has to do with the number of ways of arranging items. Combination has to do with number of ways of selecting items, choosing some specific number of items out of a given number of items. And this has several applications. For example, we have applications in social sciences. We can apply it in survey design. We can apply it in political science in terms of election, talking about how individuals interact. We can talk about it in sociology. And we can also talk about application of this in economics and so many other ways. In economics, like in market analysis and decision making. So economics use permutations and combination to analyze market behavior, consumer choices, and decision making processes. For example, a consumer has 5 products to choose from the number of ways they can make their top 3 preferences. So the number of ways they can make their top 3 preferences is given as permutation of 5, taking or picking 3 at a row or at a time. So, and that is 60 ways. They have 60 ways of prioritizing 3 out of their own products they demand actually. So, and this is the end of the video. Thank you for watching.